Good evening to all of you. So today I am going to discuss about data analytics with pandas. So pandas is a high-level data manipulation tool developed by Wes McNee. Pandas library provides data analytic features like R programming and MATLAB. Pandas is built on NumPy, SciPy, and Matplotlib packages so that it uses features of these packages. The key data structures of pandas are: one is series and another one is the data frames. Series is like one-dimensional array object, contains data and labels. Data frame is like a two-dimensional array object, stores data in the form of rows and columns. Rows represents observations and columns represents variables. So first we'll study about pandas series. The series is like a one-dimensional object containing data and labels or indexes. Series can be created in different ways using series method. For example, series S is created by using the list of values A, B, C, D, E, F. So first thing is we import the pandas and rename it as a PD for simplification. And S is equal to PD dot series of list of objects, a list of values. But when you display that list, it displays the values like this. So that is A, B, C, D, E, F, and these are the indexed values. The series contains the values of indexing 0, 1, 2, 3, 4 up to 5. Or sometimes suppose, so other way of creating is S is equal to PD dot series. Without mentioning the name of list, we can use within the square bracket to get it 2, 4, 6, 8. And when you display that S, it will having 0, 1, 2, 3 are indexes, 2, 4, 6, 8 are the values. So single value can be selected from series by using single index. The single value can be selected from from series by single index. Multiple values are selected from series by multiple indexes. For example, the first one is here is we are creating the series with values and with the titles. So S is equal to PD dot series, and within this we can use the list of items, that is a 2, 4, 6, 8, comma. After that we can mention indexes. Index is equal to F, A, C, D, F, A, C, E. So when you display this A, so here is the letters F, A, C, and E are represents the indexes, and 2, 4, 6, 8 represents values. For example, if you want to get only one value, so which is located at index A, so then we can use like this. S of within the single quotes, we can mention the index so that it displays the value 4. Or if you want to select 2 items within the series, then the 2 indexes can be represented in the form of list. So that is within the single quotes A, comma, within the single quotes C, and these 2 values are kept in between square brackets. But when you display this S, we can get A is a 4 and the C index is 6. Series is fixed length ordered dictionary. Sometimes the series can be fixed length of ordered dictionary. So ordered dictionary means suppose whatever the values are given, so that will be, the value should not be unique, but whereas in the dictionary the value should be unique. However, Unlike dictionary, index items do not have to be unique. For example, here is S2 is a series. It contains the values from 1 to 4, and each value index is represented with A, B. So here is A is repeated 2 times and B is repeated 2 times. So the same values are displaying, like A is equal to 0, B is equal to 1, A is the 2, and so that is the S2 of B is equal to 3. But when you mention like this, S of single quotes A, or so suppose S of single quotes within the single quotes A, so that will represent 4 in the previous case. But in S2, suppose when you are representing like within the single quotes, when you are getting when you are putting A, then it will print the 2 values, A0 and A2. Suppose when you keep the B, so then automatically it displays the 2 values. So that is 1 and 3. What are the operations we can perform on the series? First one is a filtering, and second one is NumPy-like type operations on data. So that means what are the operations we are performing in numeric Python? All operations we can perform on the series. So filtering means it selects number of rows, the specified row within the series, or based on the index values. So suppose when you specify the index, a particular value can be represented, or for filtering, we can use all relational operators. For example, when you see that S value, when you display the S, we are getting in 4 indexes, F, A, C, and E, and it contains the values 2, 4, 6, and 8. For example, if you want to print the values, a list of values, where the value is greater than 4, then within the list, so 2 values are greater than 4, that is 6 and 8. So here is we can represent like this, S of S greater than 4. Then it displays only 2 values, C6, E8. Or suppose when you are, so without using that square brackets, when you are using S is greater than 4, it displays all the values. But so that is the value should be either true or false. If the value is greater than 4, it displays true. Else if the value is less than 4, then it displays false. You see that 4, so that is the 2 is less than 4, then here is a false. So 4 is less than 4, so then 4 is not equal. Here is a 4 greater than 4 condition is right, that is false, and the remaining cases we are printing true. Or here is in the same way, suppose if you want to multiply all the values by 2, so then S into 2, that is equal to, so when you are S, 2 into 2 is a 4, 4 into 2 is 8, 6 into 2 is 12, and 8 into 2 is 4. Pandas can accommodate incomplete data. Sometimes suppose indexes and values may not be equal, even though it accepts that value with specifying and not a number. Suppose here is S data is series created by using dictionary. So that is the B 100, C 150, and D colon 200. So when you are making it as a series, S of D, dictionary is converted in, but actually B, C, D. So then B, C, D, need not to specify the order. So suppose the same order it will be displayed. Or suppose if you are again S data, that is the dictionary data, and a list that contains the 4 indexes, A, B, C, D. But actually in this case, B, C, D are there, but A is not there in the S data. So that's why in the position of S, it displays none, not a number. And in remaining cases, displays values 100, 150, and 200. But here is also we can do same multiplication, S into 2. that is equal to not a number into 2 is not a number, and the remaining cases 200, 300 and 400. That is 200 into 2, you got 400. Have you understood? Yes. So unlike NumPy, ND array data is automatically aligned. For example, in NumPy or ND, n-dimensional array data, so that is the data should be arranged manually. That means we have to use some sort method so that we can arrange them in the ascending order or descending. But whereas in the series, you need not to arrange them either in the ascending order or descending order. The value should be automatically displayed in the ascending order. For example, you see that in the S2, we are using PD series. So 1, 2, 3, that is the list of 3 values. And the indexes CBA. But here is we are getting CBA. Suppose when you display S2, we are going to CBA 1, 2, 3. But the same thing, suppose when you are displaying that S2 CBA, and here is S means, suppose here is S into S2, 200, 400, and so that means wherever A, but actually A is in this in third position, but in S2 S, the A is in the first position. Or suppose B is in the second position, and here is a B is in the second position, and here is also B second. So that means automatically the corresponding value should be multiplied by S into S2. A is a not a number, 2, that is B value is 2 into 3 and 150, something like this. Data. So have understood that series. Later on, we will implement some more operations on series. So the next topic is data frames. Next topic is data frames. Data frame is like two-dimensional array object, stores data in the form of rows and columns. It is just like table. Rows represent observations, that means values or records, and columns represents variable values. That is the variable names and values. It has both row and column indexes. If you want to pick a particular value, you should require both column indexes as well as row index. It also considered as a collection of series as a dictionary. So that is the table consists of a series of collection of series of dictionaries. For example, you see that. So here is series 1. This series 1 contains the apple. Here is the 4 apples are there. So suppose 0, 1, 2, 3, 4. These are the indexes. Apple 3, 2, 0, 1 plus. So oranges 0 in the 0 position, 0 apples. In the first position, 3 apples. In the second position, 7 apples. And in the third position, 2 apples. But when we are making these 2 as a dictionary, then we can get the data frame. So indexes are 4 indexes, and here is apples. So that is the 2 names. So 3201, 0371. So this is called data frame. But here is it contains the rows as well as columns. But here is when you are using the data frames or series, but how we can load the data and how that will be converted into a series or data frames. So for this purpose, here is the pandas, the data loading. Pandas supports several ways to handle data loading. Text to file data, but how to read the text to file data? So by using read_CSV instruction and read_table. If it is a table, it will read the tables by using this function, read_table. If it is a text file, that is a that extension is txt or document file, it will get the read_csv. So structured data, suppose when you are using the structured data, so that is the HTML data should be in the form of HTML or XML or JSON data works well with the existing libraries. So there are existing libraries are available. With that existing libraries, we can get the values. Suppose if the data is in Excel form, Excel sheet, then we can use, so then depends upon the first thing is we read to one package, that is the XLRD package. The later on I will give the syntax of this. So the database, suppose the panda database where we can read the names, pandas.io.sql modular read of frames. For example, first you see that. So just how to read the data and how to make the table. For example, here is we are taking the data. So this data frame method, so that is the state, and this state contains a list of values FL, GA, and GA, comma, year. So that is the three variables are there. This is like structure. So year that contains 2010, 2011, 2008, 2010, 2011, comma, pop. So 8.8, 9.1, 9.7 population, that is 9.7, 9.8. So that is entire thing from here is written in the flower brackets up to this. But here is the three variables are there. For example, if it is a student database, we can suppose if you want to read the 10 student names, roll numbers, marks, and addresses, here is we can mention that is the name, and 10 names we can write, roll number, we can write 10 roll numbers, age, we can write 10 ages, and we can use averages like this. So after that, this data can be converted into data frame by using data frame method. So here is a frame, that is a PD, that is the pandas alias name, data frame of this data variable. But when you are using that, when you display this, so that is the three variables in the population, state, and year. And this index will be automatically displayed 0, 1, 2, 3, and 4. If you want to mention the indexes, then here is we can write index. So, but when you are taking the data, here is the value should be equivalent. For example, state contains the 5 values, year contains the 5 values, and pop also contains 5 values. Suppose if pop contains 4 values, then it doesn't accept, it shows the error. This is the way of creating data frame. So same thing, suppose here also we are giving another data frame. So here is, so that is our CR. So Tausif has prepared the own table database with the XSLV file. So that is the Excel sheet. So this database, this file contains EMP, employee ID, employee name, salary, and date of birth. So that is, we are given this name as, so that is the book1.xsl. Suppose if it is a text file, we can equip it as CSV. So, but how to read this file? So, for example, here is import pandas as PD. We can rename pandas as a PD for simplification. Import XLRD package. This package should be required for reading the data from Excel. So that is, here is we can create data frame. DF means data frame. PD.read_Excel. Read_Excel. And here is we can specify the path. F, suppose if it is stored in the F root directory of F :book1.xsl. This is the name of the Excel sheet. Within the Excel file, there may be number of sheets are available as sheet 1. Or suppose if you want to read the data from sheet 2, we can mention here sheet 2. If you want to read the data from sheet 3, we can mention C3 like this. So that is with the help of this ReadExcel instruction, we can read the data and we can convert that into, so that is the data file. Here is when you are using the DF, so automatically it displays the values. You see that what are the values you had given, the same values here is it, right? So that means first thing is we can create the Excel sheet, and that Excel sheet data can be read by using the read_excel instruction. So then automatically we can convert that into data frame, right? For example, if it is a CSV, that is if the data should be stored in the text file, extension is .text or .documentation. So then for reading of that, we can use pd.read_csv, and we can specify the path name. So that is the f://edata.csv. Here is edata.csv is a text file. The text file is stored in the text file is in the F directory. When you are using the displaying the F, then employee ID, EMP, salary, and data part. Have you understood how to read the Excel file as well as how to read the CSV files? So once you read the data, and the remaining operation should be same as it is. Or for example, the same thing we are using, that is the same. And here is, for example, when you see that already we know that. So df.shape. Here is the shape instruction can specify the number of rows and columns in the data frame. For example, when you see that here is the 5 rows and 4 columns. You see that 1, 2, 0, 1, 2, 3, 4. That is equal to 5 rows and columns. 1, 2, 3, 4 columns. This is the index. You need not to consider that index, that automatically displayed. Also, suppose here is, if you want to print the value, suppose r comma c, that is df.shape. Print r means the only rows will be displaying. Print c means columns will be displayed. So next instruction is head. Next instruction is head. df.head. So already we know that the head instruction, when you are using the df.head, automatically it displays the, so the first, so the 6 values. It displays the first 6 values. If you are using df.tail, it displays the last 10 rows. And this is the first 10 rows. That is the 5, and next there is only 5 are there. So suppose 6 are there, it will display the 6. So tail means only that is the 6 values. So suppose if you want to display only a specified rows, for example, head of 2. So that means the first 2 records will be displayed, 1 and 2. If you are mentioned n, so that is the n number of records will be displayed. Also suppose, so first thing is we can find the total records in the data frame, and we can use define head of n. So then all the records will be displayed. So tail of 2, that means the last 2 records will be displayed. Also suppose if you want to display middle records, middle of the records, suppose here is a 10 to 5 records. If you want to display that, df within the square brackets, we can use 2:5. That is equal to second record, third, and fourth. That means here is, suppose it starts with 0, then we can use third, fourth, and fifth. So that is the 3 records will be displayed. Have you understood that? What do you mean by head? What do you mean by tail? And how to read the specified values? How many specified rows or columns? Like. So here is suppose df colon. Suppose when you are using the df of this, so 0 to 0 colon, and here is you are in the blank space and colon. That means all the even records will be displayed. For example, 0, 2, 4, 6, 8, 10, etc. Because here is 0, so it start with 0 colon, and here is if you are not specifying any value, it will take the nth last value, and here is a 2 means that is the increment value. So it is the increment value, and here is suppose when you are in the df 5 colon 0 colon minus 1, here is the decrement is there, decrement 1 by 1. So that will all the records will be displayed in the descending from last to first record. You see that. So the first one is 4 is displayed, next 3, 2, 1. Just like this is all even records in the descending order. So all the even records are displaying, and here is all the records are displaying in the descending order. That is from 5th record to 0. Here is we are mentioning the minus. If we are not mentioning anything, it is the positive. So suppose if you want to know the names of the columns, either that is the employee ID, employee name, salary, and date of birth. So then df dot columns. But when you are df dot columns, when you are using printing df dot columns, so then all the index values will be displayed. That is empid, name, salary, date of joining, and d type is equal to object. That means all the rows are objects, not a single values. If you want to display only particular column, or if you want to select only particular column, we can use df.empid. But when you are specifying the column, all the values will be displayed. Suppose in this employee ID, where is one, so suppose 1001, 1003, 1002, 1003, 1004, 1005. All will be displayed. Suppose if you want to display only particular column, or suppose we are using s is equal to df.empid, so then automatically it will become a series, and we can apply all the series problems. And df of employee ID, but when you are keeping this with the dot notation, only the values are displaying. So suppose here is 0, 1, 2, 3, and 5. And here is also we can display the, so that is the values as well as the name and its data type when you are using in the square bracket. Suppose if you want to display the 2 columns, then we can use the comma, so that is the salary. So then empid comma salary will be displayed. You follow? I think already I explained all operations in the dictionaries, 2-dimensional arrays, like, right? Okay. So suppose if you want to find out, so that is who got highest salary in the table. Suppose if you want to display highest salary in the table, then we can use df salary dot maximum function. This maximum function can be used to select the maximum value within the specified column. So that is the minimum function, df of salary, that minimum. When you are using that, so the minimum salary is displayed. So in this values, the maximum salary is 23,000 and the minimum salary is 10,000. So suppose if you want to display all the features like describe function. Describe function can be used to describe the, so that is the total number of records, the mean value of each column, a standard deviation, minimum, and 25%, 50%, and 75%, and maximum. That means it specifies. So the count means because the totally 5 employee IDs and 5 salaries are there, and the mean of this average, that is the mean value, is employee and this one. For example, when you are using this, so that is these two are the numbers. So say the EMP number and this date of birth are the numbers. That's why only the integer, that is the floating values, are displayed. So mean value and standard deviation. So this is a quantile graph like this. So suppose, so what are the values within the minimum range, and what are the percentage of values that average values in between minimum to 25%, and 25% to 50% range, 75, and maximum of this one. Already we have seen that the maximum value is this one, mean of this one, and the minimum value is 1000. So that is here is the 1200. This is the 25%. The range minimum 10,000 to all the record 10,000 to 12,000 range. So suppose if you want to display the records, display the records where the salary is greater than 10,000. So then here is we can write like this arithmetic operation, relational operations. So df, so within the square bracket we can use df dot salary greater than 10,000. So then all the records, that is the 4 records have been displayed. So the 0th record not displayed because the 0th record contain the salary 10,000. But here is we mentioned greater than 10,000, right? And here is df that salary greater than 10,000. The same we can use. So then here is df salary. Suppose if you want to see that, so that is the only the maximum salary you have to display. So that is the double equal to means equal. Suppose here is df within the square bracket, df dot salary is equal to df dot salary dot maximum. So then here is, so that maximum salary record will be displayed. For example, df dot salary dot df dot sal dot maximum. Then here is, that is the record will be displayed. There is only one record which is having the maximum value to 3,000. Right? So already I explained. Suppose if you want to display 2 columns, we can df. So these 2 columns will be represented within the list. You see that 2 square brackets are represented, 2 open square brackets, 2 square. That means this will represent list, right? Okay, all the 5 records will be displayed. Have understood? Okay, right. Thank you. So next index. Suppose if you want to see that index, so that is the index function can specify. So that is the starting index and last value and the step. Suppose here is a range of index that will be starting is equal to 0, and final index is, that is the stopping index is 5. That means 4 up less than 4, step is equal to 1. So 0, 1, 2, 3, 4 up to 5 values will be displayed. Starting index, ending index, and this one. Sometimes it may be useful for finding how many records are there in the data frame. Right? So suppose if you want to set the set indexes, suppose if you want to specify the by default it is giving index 0, 1, 2, 3, 4 or something like this. So sometimes, so our roll number is also unique for the students, our employee ID is also unique for employee. Suppose if you want to represent employee ID as an index, then we can use set index method. df1 is equal to df dot set underscore index, set underscore of EMP ID. Then when you are displaying the df1, so this is the indexing value. This is index. So here is, you need not to use, that is the serial number like 0, 1, 2, 3, 4 up to n. Or here is set index. So in place, suppose when you are using that, the place of this, all the values will be representing like this. By default, it is true. So suppose here is when you are using the df dot location. So the location means when you are using the 1004. So then the particular location it will be displaying from. So salary is this one, job of this one, 1004. Suppose this is a 1004. So the salary is equal to this one, and next, so that is job is equal to this one. So sort values by date of birth. So data joining. Suppose sometimes if you want to arrange them in ascending order or descending order, by taking a particular value or suppose date of joining, so then we can use. Suppose if you want to give the seniority for the employees, we can consider data join. So that is a sort underscore value function used for adding them into the descending order. So suppose the based on the data sort value data birth and ascending order is a path. So that is you can make it as ascending order or descending order. Suppose the true means values will be displayed in ascending order, false means values will be descending order. So suppose it is we can consider the two columns for arrange them in the ascending order or descending order, like SQL. Say we can use the values. So already we mentioned that. So suppose you see that. So in this table, here is some values are null. So how to eliminate? If you want to improve the data, then we can eliminate the null values, right? So for this one, for example, you see that in this frame, not a number and not a number, not a number. So if you want to remove this, suppose when you are using this not a number, if you want to find out the mean, average, sum, it is not possible because it is not a number one. So then here is we can replace this not a numbers with the specified values. For example, so for this one we can use df dot fill na of 0. That means wherever you find the not a number, there we can use 0, 0.1 and 0. Like this, right? So suppose if you are in the fill number, so the name is missing, or salary 0.0, date of birth 00. For example, if the name is missing, so then this value is displayed. So in that place, name is displaying, the string will be displayed. If there is a salary is and not there, then in that place it replaces 0.0 and the date of joining. So that is 0000 will be replacing. For example, you see that. So 0.00000. Also suppose a drop, so if there are more number of missing values are there in the data frame, then so instead of replacing with zeros, then we can delete all the rows so which contains 0 values are not a numbers. For example, for this one drop NA, we can use drop NA method. Drop NA method means so it displays wherever. Suppose here is the 00, so third record is deleted and the second record is also deleted. So that is answer that drop NA. Drop NA means it deletes the rows where the values contains 0. So that is a fill NA means wherever blank spaces are there or not a number can be replaced by the specified values. If we keep 0, it will replace 0, or mean value it will replace, or mode value it replaces mode value, right? So have understood this. So some of the applications and examples of this one. So here is really, so that is all the operations. Here is the program is also available for this. So that is I prepared, I executed. So all the instructions of that is of pandas, and I kept the instruction as well as output of data frame. So for example, so for this one I have taken already I explained that pandas built on NumPy, SciPy and Matplotlib. If you want to draw the graphs, so graphs for Matplotlib instructions can be used, or if you want to perform any arithmetic operations, we can use the numeric Python can be used, and scientific operations or anything can use Python. So here is the import pandas as PD. From pandas import data frames and series. So first you see that first here is I am creating one frame with a different list. For example, DF pd dot data frame. So here is, this is the list, one list, 1, 2, 3, 4, 5 values, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So that is, here is this contain the 6 lists. That means each row that contains 1, 2, 3, 4, 5, 5 columns. So 5 columns, 1, 2, 3, 4, 5, 6 rows. And index for each column name we can specify. Index is 1, 2, 3, 4, 5, 6. And column names we can mention it as A, B, C, D, E. So the columns are a list and index is list. But when you print the value of DF, when you print this DF, we can get the output like this. Columns A, B, C, D, E. And here is indexes 1, 2, 3, 4 up to 6. And these are the values, right? So then this is a creation of data frame. After creating the data frame, then so we are giving the information. Suppose here is a printf information about the data frame. Here is this contains information. But when you are using df.info a function, when you are using info function, it displays entire information about the data frame. For example, so the class name is data frame, and here is it is a 60 integer, 60 data type is integer data type, and size of that is 64-bit. So 6 entries, that means number of rows are 6, 1 to 6. So data column, so that is the 6 is 64, 64 ABC. First column, second column, third, fourth, and the fifth column. Data type is integer of 5. So the memory usage 288.0 bytes, right? So that is information, df.information when you are using like this. Already I explained that. So dfh header. So head of 2, but here is n is equal to 2. When you are displaying head of 2, so the print instruction and print is, that is the 2, 1 and 2 rows will be displayed. The values will be getting like this. And df tail of n. So then here is 2, last 2, 5 and 6. Last 2 are displayed. Describing the same function, df dot describe. dfs dot describe means here is the count is equal to 6 to 6. All the columns contains the values of 6. The mean value is the mean value of first column 4.5. Second column 4.50040. Say B 7.50040. D 10.540. 6, that is a 22.667, 27 of the standard deviation of each column, that is 0.8, 0.8 something, 0.8 or something. So minimum value in the A column A, the minimum value is 4, column B minimum is 7, 10, 20 and in the 5. So 25 is 25, 25, 50, 40, 40, 40. So these are the description of values. So suppose if you want to this is a transpose of the frame, then we can use df dot capital. So automatically it will display the rows by columns, columns by rows. So suppose if you want to display the bit columns, so suppose here is df dot columns. When you print the df dot columns, we display the columns only A, B, C, D, E or something. Label. Suppose if you want to get the only column of 0, first column you can get the only first column is A. Suppose if you want to get the second column, you can use 1. Third column 3 or something like this. So column 2 series. Suppose you print the, so that is the 2 list. So all the columns, if you want to print a list, we can convert them into list. So select column to series. This is select A column as a series. Or column to data. So suppose when you are given the series, series to dictionary, we can write like this: df within the square bracket a, like this, 2, 2, 2, something like this. Change order. Suppose in the frame that contain the columns A, B, C, D, like this. A, B, C, D. Suppose if you want to change the order of the columns, we can use the changed list can be say df within the square bracket. We can put the list C, A, B. Then automatically. So first C column will be displayed, next A columns, and the next B column is displayed. So suppose if you want to display the order, suppose column name by numbers, F, df dot columns 0, 3, and 4. So then 0, 3, 4 will be displayed like this. Indexes, that is already we know A, B, E indexes, because after that the values have been changed. That's why here is the values have been changed. Row index, so then indexes. So label, suppose if you want to first row label, then we can use in df dot index of the image. So that is the first row is 1, 1 to 3, 1 or something like this. If you want to convert that index list, then 1, 2, 3, 4 up to. Okay, later I will explain how these things. So today I stop my lecture with these values. So are you following? If you have any doubts, make me comment. Right? Thank you. Right, the close.
Fine, stop share. Fine.